So we have to find the equation of a plane that passes through this given point, -2, 1, 2, and contains the line of intersection of these two planes. Okay, so the first thing to verify would be this, that the point itself is not on the plane, because then we will not have the plane. There could be many planes then, right? So let's see. So I substituted the coordinates of the points on in the first equation. That is not satisfied, right? And then I'm going to substitute the coordinates. I mean, you can smartly just observe and tell if you want. Okay, so there we go. So we have this here, and you can see it is false, but let's just make sure anyways. So our next strategy will be to go ahead and find 2 points on the intersection of these two planes. Okay, and then we will have a plane through 3 points. So let's just go by a very basic way. Okay, so we may do this. We got these two, right? So what we can see is right here that if we added these two equations, the y's will cancel, right? So you get 3x plus 3z equals 3, which will give you x plus z equals 1. Now let's just set a value for z. Say set z equals 0. If you set z equals 0, x will be 1, and use any of these two equations, right? So here, say we have z equals 0, x equals 1, then y will be what? 1's will cancel and y will be 0. So easy enough, we have 1, 0, 0 as one of the points, right? Okay, now next we may do this. Let's just set z equals 1. If we do that, then what will happen? Just a second. It's okay, one moment. Right here, sorry about that. Okay, so then x will be what? 0 if we substitute z equals 1. Now here, if I substitute z equals 1 and x equals 0, y will be how much? Y will be, I can use either of the two equations, y will be 2, right? Okay, so what does this give us as a point on the plane? We get 0, 2, 1 as another point, right? Now, so we have to find equation of the plane that contains these 3 points. Which 3 points? One of them being this. Okay, all right, and then we have this point right here and this point right here. Okay, all right, so what we will do is, so we know the plane contains the point -2, 1, 2, and these will be 2 other points on the plane. So let's create 2 vectors, take their cross product so that we can obtain a vector that is perpendicular to the plane. Okay, so let's just first use these two guys here. Okay, so we are going to find or determine or compute the components of a vector from 1, 0, 0 to 0, 2, 1. So what that vector will be? The vector will be we go 0 minus 1 is negative 1, 2 minus 0 is 2, and then 1 minus 0 is 1. Okay, and then we would do what? We will take another one. Let's just keep 1 0 0 as our initial point. So we'll keep the things easy. So 2, here the other point was negative 2 1, and the z coordinate is 2, so that vector will be what? That vector will be negative 2 minus 1 is negative 3, then 1 minus 0 is 1, and then 2 minus 0 is 2, right? So what we would do now is we are going to just find the cross product of these two vectors, right? So here we go. We got this cross product with this vector, right? And then we have this determinant. Okay, so negative 1 2 1, and then we have negative 3 1 2, right? And what that will give us? That will give us a vector that is perpendicular to the plane that we desire. So that is like, say, 3, because when I look at the first components, 4 minus 1 is 3. For the second one, negative 1 plus 2 is negative 1, and for the third component, negative 1 plus 6 is 5, right? So what we have is that we want the plane through. So let me take our easy point, that is 1 0 0, will be easy to compute. I mean, we know original question said this, but that will be contained anyways, right? And perpendicular to this vector right here, all right. Okay, so what that equation will be? That will be, as you know, you can write it directly by using the dot product, right? 3 times x minus 1, then minus 1 times y minus 0, plus 5 times z minus 0. So the dot product has to be 0. So what an equation of the plane will be? 3x minus y plus 5z equals 3. All right, okay, and I shall show you a graphical sketch later. Okay, so let me know if you still have any questions.